Welcome students. Today we are going to see about unified approach. Unified approach is a methodology for developing a software. Here in this methodology, we will be combining the best practices of Booch methodology, Jacobson methodology and Ramberg methodology. So this Booch, Ramberg and Jacobson is also the methodology which are used for developing a software. So our unified approach will be taking the best practices out of these three approaches or three methodologies, and the best practices is used for developing the software. So as our unified approach is taking the best practices out of Booch, Ramberg and Jacobson methodology, this is giving you an unified framework, unique framework for developing a software. In order to develop a software using unified approach, you will be using the UML diagrams and notations. UML in the sense Unified Modeling Language. So this Unified Modeling Language gives you a various set of notations and various set of diagrams. Using these diagrams and notations, you will be developing the software in our Unified Approach method. So using this Unified Approach method, you can able to understand easily the concepts of object-oriented programming as well as how the software can be easily developed using that object-oriented concept. So this the user can easily able to understand, the developer can easily able to understand. So that is why we are moving to unified approach. In unified approach, basically you will be using the UML language, notations and diagrams. Unified approach has 5 basic processes. Let us see what are all the processes and what we are going to do in those processes. Unified approach has 5 processes. First one is use case driven development. Here you will be having some use case models. Based on the model, the software is going to get developed. So this is the first process. The second one is object oriented analysis. You will be analyzing the object oriented concepts so that how our software can be developed using this object oriented concepts. Third one is object oriented design. So in this phase, after analyzing the software development, so you will be moving on to designing phase. In the designing phase, you will be using the object-oriented programming concepts to design our software. The next thing is incremental development and prototyping. Incremental development and prototyping. Incremental development and prototyping is a special process in unified approach which is making our unified approach unique from other methodologies. The fifth one is continuous testing. So these are the 5 processes what we have in unified approach. First one is use case driven development. Second one is object oriented analysis. After that we will be moving on to object oriented design, and then you will be performing incremental development and prototyping, and then you will be performing continuous testing. So these are the 5 processes in unified approach. In order to perform these 5 processes one by one, we are in need of some techniques. So our unified approach will be using some techniques. So you have some 4 techniques in unified approach. So those 4 techniques are UML language, that is Unified Modeling Language. So using this UML language, using the notations and diagrams what we have in UML language, you can able to develop the software easily. Second is layered approach. So layer approach is a technique. It is some special technique using which you can process these 5 processes. Third one is repository, and the fourth one is component based development. So these are the 4 techniques. Using these 4 techniques, you can perform these 5 processes in unified approach. So let us see the processes and techniques in detail in the following session. Let us see a diagrammatic representation of how the 5 processes of unified approach is done one by one using the techniques what we have introduced in unified approach. Let us see it with a neat sketch diagram. This is the overall diagram of how a software is developed using an unified approach. So in the unified approach, you have the 5 processes. Let us see the 5 processes in detail using this diagram. First is object-oriented analysis phase. In this object-oriented analysis phase, you will be obtaining the responsibilities from the user, system responsibilities from the user. First, in the OOAD analysis phase, you will be identifying the problem, the domain of the problem, and then system responsibilities by knowing all these user needs. Object-oriented analysis has the following steps like, in the object-oriented analysis phase, you will be identifying the user. After identifying the users or actors, you will be developing the use case diagrams and activity diagrams as well as prototypes. So you have various types of prototyping. So you will be developing the prototypes for our software. And then the next step is to create interaction diagram. So after developing the interaction diagram, you will be identifying the classes and the relationship between attributes and methods of the classes. So all these things will be identified. After this, you will be refining and iterating. So refining and iterating in the sense, the previous 4 steps will be refined and iterated frequently in our object-oriented analysis phase, so that any changes can be made at any time of development and analysis. So any changes can be made at the time of analysis as well as any changes can be made at any time of designing. So this advantage is given by refining and iteration process. So this is one special concept of unified approach. This is one special feature of unified approach. So OOAD analysis phase is the phase in which you will be identifying the actors first, and then you will be developing the activity diagram plus use cases, followed by you will be developing the interaction diagram, then classes and its relationship. Then you will be refining these steps and iterating these steps. So this is completed in OOAD analysis first. Next, we will be moving on to OOAD design part. In the OOAD design part, you will be combining the designing methods of all the 3 methodologies like Jacobson, Boch and Ramberg. So you will be taking the Jacobson's methods, analysis and interaction diagram, and then you will be taking the object diagrams from Boch methodologies, and then you will be taking the domain models of Ramberg's methodology. So you will be taking some diagrams from all the 3 methodologies so that object-oriented design part can be done efficiently. The next is object-oriented design phases. You will be first designing the classes and their attributes, methods and structures. So first you will be designing the classes. So in the analysis part, you will be identifying the classes. In the design part, whatever classes we have identified, it will be designed. And the attributes and methods, the structures, what we have in the classes will be defined. And then you will be applying the design axioms, in the sense, if some rules are there for designing the classes, those rules and conditions can be applied when developing these classes. Then you will be building the UML class diagram after designing this class. So after designing the classes, you will be building the UML and class diagram. So after creating the UML and class diagram, then you will be creating the user satisfaction test as well as design layer and access layers. So you will be designing the view and access layers and some prototypes, and then you will be developing the user satisfaction and usability test based on the use cases. So these are the steps you have in object-oriented designing phase. So in the object-oriented designing phase, first you will be designing the classes and the attributes and methods what we have in the classes. After that, you will be building the UML class diagram, and then you will be moving on to designing the layers like view layer and access layer as well as some prototypes. So after developing these layers, you will be performing some tests like user satisfaction test and usability test. So these steps will be iterated frequently. As these steps are iterated frequently, so here again OOAD design analysis part is again giving you an refined designed part or refined software development. So each and every step can be refined at any stage of development. That is the special feature given by our unified approach. Next is we have iterative development and continuous testing. Iterative development and continuous testing in the sense, here this line indicates our algorithm or our unified approach is making us to make some changes at any part of system development. Here also in OOAD analysis part, this line represents any changes can be made at any part of OOAD analysis part. So you can iteratively refine your process at any stage of development. To perform OOAD analysis and OOAD design part and iteration and continuous testing part, you will be using some techniques. First is UML based modeling. You will be using UML based notations and diagrams for performing these processes, and then you will be using the layered approach. Using the layered approach, you can help the unified approach to develop the processes. Then you will be using the repository, and then you can use component based development. So these are the techniques which is used to develop the OOAD analysis and OOAD design part as well as iteration and continuous testing part. Let us start with UML based modeling part. UML based modeling in the sense, unified modeling language will be having some notations and diagrams. Using those notations and diagrams, you can develop the software. Next is layered approach. In layered approach, you will be having some 2-tier architecture and 3-tier architecture features. You can use any of the layered architecture and you can develop your software. The next is repository. Repository in the sense, it will be having the collection of use case designs, user interfaces, past experiences, what we have when we are developing the other softwares, patterns what we have used in other softwares, documentation what we have developed for the previously developed softwares, traceability in the sense, to reach a solution, what are all the steps we have to do. So the traceability can be obtained from previous software developed. So repository will be having the collection of past experiences and past patterns. So using these experiences and patterns and use case diagram, we can use the same patterns and same documentations what we have already used in the previous softwares developed in our new software. So we can reuse those use cases and documentation or experiences. So you can reuse the models what we have in repository. So repository is a technique which is allowing the developer to reuse the models what it has. It is allowing the user or the developer to reuse use case diagrams, reuse the patterns, reuse the traceability what we have obtained from developing the software in the past experiences. The next technique is component based development. So we have already seen in the previous sessions what is component based development. In component based development, each and every model will be developed as a separate component, and each and every component will be like a working part of the software, and those components will be continuously tested. So if one component is made any change, the previous components is also will be getting affected. So the components is continuously tested. So it has to satisfy the user satisfaction and usability testing. As it is a component based approach, as we are developing some components for creating a software, these components should satisfy the quality assurance test. So the quality assurance test will be having some processes like validation, verification, correspondence and consistency. So those tests has to be assured by our component based development part. So these techniques are used to develop the software using the unified approach. Next we are going to see about layered approach in software development. So if we are using layered approach for developing a software, we have two ways. You can either develop a software using 2-tier architecture, or you can develop a software using 3-tier architecture. Let us see what is a 2-tier architecture and 3-tier architecture. This is a 2-tier architecture. In 2-tier architecture, you will be having a workstation and data. That is, workstation will be able to collect the data directly without having any intermediate. Here there is only two layer, that is interface and data. So data will be there in the data source. Interface is our system, or interface is the user what we are who is going to contact the data source for getting the data. So interface will be used to collect the data. So you have only two layers here, so that is why it is called as 2-layer architecture. So you will be having a workstation, and that workstation will be directly contacting to the data server and it will be obtaining the data. So this approach is called as two-layer architecture. But this two-layer architecture cannot be reused easily in other projects. So as it is not allowing the reusability property, we are moving on to the next approach called three-layer architecture. This is the three-layer architecture. Here also you will be having the interfaces and data, but between a workstation and data you will be having some set of servers. For example, let us consider a simple step in our software, that is user verification. Let us consider we are having a model called user verification model in our software development phase. So if we want to verify a user, first you have to get the username and password from the user, and then you have to check whether the username and the password is valid or not. So this username and his corresponding password will be saved in the data part. So the system will be working like, first in the workstation, the user will be giving the data like username and password. So this will be in the workstation. From the workstation, this data will be sent to the server, which is in the middle cloud part. So the server, it will be taking the username and password which is sent from the client, and then this server will also get the corresponding username and data from the data source. So the server will be getting the data from both the workstation as well as data source, and it will be making a match for it, and it will be verifying whether the username and password is same as that it is stored in the data source. So this center part is called as cloud part or server part. So this will be this will be used to connect the workstation and data. So as we are having three layers, this architecture is called as a three-layer architecture. In three-layer architecture, you can reuse the components what we are using in software development. So most popularly, we are using this three-layer architecture. In object-oriented software development, the three-layer architecture will be having three layers like access layer, business layer and view layer. So this diagram typically says how the access layer, business layer and view layers will be communicating with each other. So first we will be seeing about the business layer. In the business layer, you will be having all the objects which will be representing the business. So business layers will be having the objects, and these objects will be representing what actually the business is doing, what actually the software is going to develop. Here the responsibility is very straightforward. Model objects are business. Here the work is to model the objects to develop the business. How the models or the objects are communicating with each other to exactly create the output of the software. So this business layer will be giving you the objects. So those objects will be the business objects. The next we will be seeing about the view layer. View layer is the outermost layer, that is here the user will be interacting with the system. So this layer will be the user interacting layer. So it also consists of objects. So the view layer will be having some objects. With the objects, with the help of those objects, user will be able to interact to the business layer and access layer. So the control will be in the hand of interfaces what we have between the view layer and business layer. This layer is responsible for two major aspects. One is responding to the user interaction, and then it will be displaying the business objects. So this is responsible for two major aspects. The third one is access layer. So this access layer will be also containing some objects. So these objects will be able to know how to communicate with the place where the data actually reside. So it will be able to communicate with the data. So this has two responsibilities. One is it has to translate the request what is given by the client, and it has to translate the result what is generated as an output of the client's request. So access layer is the one which is translating the user request and user result. So these are the three layers what we have in software development process in using object-oriented method. Next is modeling. Modeling refers to an abstract representation of our system. Modeling in the sense we will be developing an abstract model of our system. So using that abstract model, one can able to understand how our system will be performing, what is the initial step, what are all the steps we have in the middle, and how we can finally reach the solution. So by seeing a model, by seeing an abstract representation of the system, you can able to get an overall view of how our system is able to work. So modeling is very useful. Modeling can be either a static modeling or it can be an dynamic model. Let us see what is a static modeling and dynamic modeling in detail. Static modeling in the sense you will be having an snapshot of system at any point of time. So just it will be giving you a snapshot of the current system. So as we are getting the snapshot of the system, it is an static one. So it gives the static aspect of the system, and then it does not changes over time. It lacks changes. So it is not changing over the time. For example, you will be having the UML class diagram. UML class diagrams are the diagrams which represents what are all the class you have in softwares, what are the attributes, what are the methods you have in those classes. So this class diagrams represents the static model of our software. These class diagrams will not get changed over time. So this is a static representation. The next is dynamic modeling. Dynamic modeling will be representing the system. So will be representing the system's procedures as well as the behavior. So it will be having collection of procedures or behaviors of our system. So these procedures and behavior will be changing over time. So that is why it is called as dynamic modeling. So in dynamic modeling, you will be able to get the collection of procedures and behaviors of our system, and these procedures and behaviors will be changing over the time. The next is, it will be changing over the time. So it shows the relationship between business objects and the task what these objects will be going to perform. Business objects and the task it is going to perform. So the example for this is UML interaction diagram. UML interaction diagram says how the business objects are interacting with each other, how these interactions will be changing over time. So interaction diagram is the example for dynamic model, whereas class diagram is the example for static modeling. Then we will be seeing the uses of modeling. Why actually we need modeling? So let us see what are all the needs for modeling. First, modeling is very similar for building a blueprint for the system. It is like a blueprint. So by knowing the modeling, you can know how and the way the software is going to develop. So it gives the blueprint of software. And then a modeling language must include all the three features like modeling elements. So what are all the fundamental concepts and semantics what we are going to develop in a software, and then the notations what we are going to use in developing the model. Next is guidelines. So using this guideline and seeing this model, one can able to develop the software. So this modeling language must have these three details or these three concepts in it. Next is, Turbin is an author, and this author states modeling has the following advantage. One is, modeling makes the easier way of developing a software. It makes easier for completing the difficult task. So it is making us to complete the complex task easier. Next is, it reduces the complexity. This model enhances the and reinforce the learning and training part. It performs cost of model analysis, and then manipulation of real world system is very easier in modeling. So according to the author Turbin, he says modeling is very easier for completing the complex tasks. So it reduces the complexity. This model enhances and reinforces the learning and training part. Cost of model analysis is low in modeling the software. manipulation of real system is very easier in modeling the software. So in today's session, we have seen what is an unified approach and what are all the 5 processes we have in unified approach and some 4 techniques which is used to develop those processes. So then we have seen some layers like a 2-tier architecture layer, 3-tier architecture layer. So in 3-tier architecture layer, we have seen some layers like business layer, view layer and access layer. And then we have seen what is modeling, why we need modeling when we are developing a software. So the use of modeling has been discussed in today's session. So thank you for the session.